Hey guys, my name is Hari Masoor from Physics 2211 section NO2, and today we will be talking about Lab 3. The problem in this lab is that a star is orbiting a black hole of unknown mass. We want to find this mass. To do this, we'll use the momentum principle at Newton's law of universal gravitation. We will also decompose F-net to parallel and perpendicular components. I do this in the Python computational model to show. The information given to start this lab was the mass of the star as 4.5179 to the power of 10 to the 27th, the time step as 1 day, the black hole position as 3 times 10 to the 10th for the x-axis, negative 2 times 10 to the 10th for the y-axis, and 0 for the z-axis, and the origin at 0, 0, 0, and the gravitational constant, which is 6.67 times 10 to the negative 11th. This is the result of my computational model. The green color shows the trail of the star as it orbits the black hole, and the 3 arrows are the different forces acting upon the star. All the different formulas you see on the screen are derived from Newton's second law, which is change in momentum over change in time. And all these different formulas were used in my code to help me find the orbit of the star around the black hole. Newton's law of gravitation, as everyone knows it, is F-net equals the gravitational constant times mass 1 times mass 2 divided by radius squared. I manipulated this in my code, as you can see below, and as it read exactly in my code, it was m whole, which is the mass of the black hole, equals magnitude F-net times magnitude star position minus hole position, all raised to the second power, divided by the gravitational constant times the mass of the star. Given the initial conditions, the CSV of the star positions, and Newton's law of universal gravitation, using my Python code, I was able to find the mass of the black hole, and I had found that it was 4.1792502187341 times 10 to the 31st. To put that in perspective, that is about the size of 21 suns and over 6,982,585 times the size of Earth. The what if question states, imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? To answer this, all I really need to do is show you the formula, Newton's law of universal gravitation. Because in this formula, the gravitational constant would stay the same if the new black hole was there. The mass of the star would remain the same, and because it says the motion of the observed star remains unchanged, the distance away from the black hole would remain the same. So the mass of the new black hole would be exactly the same as the mass of the old black hole. Therefore, according to this formula, it would not be possible to find out if there was a new black hole there. Thanks for watching, and I hope by watching my video you have obtained a deeper understanding of Newton's law of universal gravitation.